Hi, I'm Captain Steve for BoatTest.com, and today I'm here on what I think is a very important mission for every boater who's trying to get peak performance out of a boat. It was almost exactly 2 years ago that we tested the radically different Sharrow prop, and it was an invention of Greg Sharrow nearly 10 years before. And during that previous 10 years, Sharrow had secretly developed and refined the design of his new prop concept, collaborating with some of the most expert prop designers, testing facilities, and manufacturers in the world. Our test 2 years ago was the first time that this unusual prop was introduced to the world at large. We took a Sharrow aluminum prop and put it on a single 150 horsepower Mercury outboard that powered a 20-foot bow rider that weighed 3,543 pounds. We then tested the boat with two other stainless steel conventional props so that we could compare the difference in performance among the three props. What we discovered was that this radical prop design was also revolutionary. We found that the Sharrow prop was faster at all RPM settings, planed at lower RPM, and had more thrust in reverse, stuck to the water in tight high-speed turns, and had significant improvement in miles per gallon at nearly every speed setting, particularly in the mid-range.
But over the last 2 years, people have asked if this was just an anomaly. Some prop experts even said that every prop has its sweet spot application, and Sharrow just happened to find the boat best suited for its design. While the Sharrow props might be better on a small lightweight monohull with a 150 horsepower Mercury outboard, how would they do on a larger, heavier boat with a different hull shape and powered by twin 300 horsepower engines?
To answer all these questions and more, Sharrow Marine asked BoatTest to once again test their props and compare them to the standard stainless steel wheels the engine maker recommends.
This time, we're testing a 32-foot WorldCat catamaran instead of a monohull with two 300 horsepower Yamaha engines instead of a single 150 horsepower Mercury, and a boat weighing 13,694 pounds, 4 times heavier than the one before, with 4 times the horsepower. The first props we're going to test on the Yamaha engines are the ones that come standard. Yamaha's Saltwater Series 2 3-blade 15 3/4 inches by 15 props. So let's get aboard and find out how the Sharrow props stand up to a Yamaha top-of-the-line prop. The most important data for any prop is its mid-RPM range performance, so if you're only interested in top speed, we're saving that little goodie until the end. The average boat owner operates his boat about 60% of the time in the mid-range, and for fishermen and anyone going far from the fuel docks, range is the most important data point. With the Yamaha Saltwater Series 2 prop, we found best cruise, which we define as planing speed with the greatest range, to be 4,000 RPM and 23.8 miles per hour. At that speed, we were burning 21.2 gallons per hour and getting 1.1 miles per gallon for a range of 282 statute miles. We tested the boat from idle all the way to wide open throttle, and I'll show you all the data when we compare the two props in a minute. After our test, we hauled the boat, then we swapped the Yamaha props out for the Sharrow props. Boat weight is critical to performance, particularly on a catamaran, so we topped off the fuel and had the same 3 people aboard testing the Sharrow props. Sharrow props are made for every specific boat and engine application and are different from one application to another. The 15.5 by 15.4 inch Sharrow props we tested were made specifically for a 325 DC WorldCat with twin 300 horsepower Yamaha engines. We found the Sharrow prop's best cruise to be at 3,000 RPM, where the boat went 21.7 miles per hour, burned 14.8 gallons per hour, and got 1.5 miles per gallon for a range of 368 statute miles. Now, let's compare best cruise speed data for both props, and it's here where we find a remarkable contrast of performance. First, we note that the Sharrow prop's most economical RPM is a full 1,000 RPM less than Yamaha's, but it's 2.1 miles per hour slower. The Sharrows burned 6.4 gallons per hour less at their best cruise compared to the Yamaha, and this is one big critical difference. This huge decrease in fuel consumption means the boat can go 1.5 miles per gallon or 36% farther on a gallon of fuel than can the standard prop. By being significantly more efficient at best cruise, the WorldCat 320 with Sharrow props can travel 86 statute miles farther than with the standard props. For fishermen going out to the canyons and back, that 86 miles can make a big difference. Now when we take all of our test data for both props and plot them on a graph, here's what it looks like. In all of our charts, the blue line is the Sharrow prop and the orange line is the standard prop. At idle, the Sharrow prop is 24% more fuel efficient. And while you think that you may not run the boat much at idle, the fact is that the International Boating Industry Association, ICOMIA, says that 40% of the average engine's duty cycle is at idle. So that increase in fuel efficiency of 24% can add up. The next thing that becomes obvious is that at 10 miles per hour in this graph, something dramatic happens. Note that the fuel efficiency of the Saltwater 2 prop plummets precipitously to just 0.8 statute miles per gallon. That's because the boat is trying to get over its bow waves and just isn't able to deliver to the water the torque needed to do it at 2,500 RPM. On the other hand, the Sharrow props at this RPM are now approaching peak efficiency, getting 1.4 miles per gallon, 75% more miles per gallon. The boat with Sharrow props attained planing speed at 16 miles per hour. The Sharrow prop allows the boat to plane at a lower RPM, burning much less fuel. In the 20 to 25 mile range, the Sharrow props keep their 36% mile per gallon average, and it's not until over 30 miles per hour that the gap narrows. At 35 miles per hour, the efficiency of the two props is about the same, so boaters running the 320 WorldCat at or near wide open throttle will get about the same miles per gallon with both props. Most boat buyers want to know what the top speed of a boat is, even though they almost never run the boat there, so let's start at wide open throttle with the Yamaha props. We reached a top speed of 41.6 miles per hour. Top speed of the boat with the Sharrow was 42 miles per hour at 5,500 RPM, or 0.4 miles per hour faster. When we compare top speed for both props, the difference is not much, but it's pretty impressive for a prop that also shellaxed a standard prop in the mid-range of fuel efficiency. Historically, props have been designed to either be fuel efficient in the mid-range or fast, but not both, unless it's a conscious compromise. The Sharrow prop gives the owners the best of both worlds without compromising speed for efficiency. As can be seen in this graph, the Sharrow prop is faster across the entire RPM range, from idle to wide open throttle. In a critical mid-range, where most operators travel, from 3,000 to 4,500, the Sharrow prop is from 15% to 105% faster. Now, let's take a look at haul shot times. Determining when a boat actually gets on plane is an inexact science with a monohull, but with a catamaran, it's even more difficult to pinpoint. For that reason, we'll just look at the 320's time to attain 3 speed gates. The Sharrow props outperform the standard props at haul shots at every speed. So let's summarize our comparison test of the Yamaha Saltwater Series 2 props versus the new Sharrow props tested.
When I got back to my office after the test and carefully looked over the data, I realized the Sharrow prop checked all of the boxes. Solidly on plane at 3,000 RPM, faster at all RPM, 15 to 33% faster from 3,500 to 4,500 RPM, 30% greater range. But some of the Sharrow prop's attributes are hard to measure empirically, but she definitely has much greater thrust in reverse, making the boat easier to dock. There is noticeably less vibration at cruising speeds, and there was superior handling in tight turns at high speed.
Now, let me hasten to point out that there's nothing wrong with the Yamaha Saltwater Series 2 prop, any more than there was a problem with the standard prop brands we tested 2 years ago. The Sharrow's performance superiority has nothing to do with brand, geometry, or maker. It's simply new technology versus old technology. For another analogy, think of when the railroads in the 1950s moved from steam locomotives to diesel ones. The steam engine certainly worked, but they've been around for 130 years, and the new diesel technology was simply better. So the question that everyone is naturally asking is, how is it that a propeller invented by a young man who was an executive producer and director in Philadelphia with no engineering background was able to invent a new prop design that is dramatically better than what the greatest minds and engineers in the prop world were able to create in the last 100 years? It turns out that Greg Sharrow, in a former life, was trying to solve a noise problem caused by the blades on drones that he was using to take videos of an orchestra in a theater. Some basic reading pointed to the phenomenon called propeller tip vortices. If you've ever heard of a helicopter's whap whap whap, you know how noisy this can be. The helicopter in high humidity day illustrates the vortices which cause the noise. The same thing happens on prop planes. The same thing happens on propellers underwater. Prop vortices are the same, and instead of creating noise, they create drag which slows the prop. The genius of Greg Sharrow was in getting rid of the blade tips by creating a loop that in the case of the drone eliminated noise, and in the case of boat props, virtually eliminates drag. Years of tank testing at the University of Michigan proved that Sharrow's loop prop design performed much better than conventional marine props. Sharrow called in some of the most prominent propeller engineers in the country to help him develop his concept. Over the course of 10 years of development, these experts realized that the loop prop design had a second attribute that was even more important than eliminating the blade tip vortices, and that was its advance rate through the water was significantly better than conventional props. But that aspect of the Sharrow secret sauce will have to wait for our next Sharrow video, which will be coming soon. In the meantime, in case you're wondering, Greg Sharrow has found 3 different foundries to cast his props and says he's planning on making 10,000 props next year. Further, he tells us that the prop design we tested in this video is available specifically for Yamaha 300 horsepower engines. To find out more, go to sharrowmarine.com. For BoatTest.com, I'm Captain Steve. We'll see you on the water.